Hi guys, this is Mrs. Archer. I am here to show you our stream table lab in case you missed it. So here's our setup. We have a pan with some sand in it. Notice that it's propped up on some wooden blocks, and on the ring stand we have a cup. In that cup there's a tiny hole that's drilled in the bottom so that water can flow through that. I've got rulers here to measure heights. Got a graduated cylinder that I've used to measure out the water that we'll pour in. And notice I've got one cup that's at a low height and one cup that is positioned much higher. So my first step is I'm going to take some measurements of the cup heights and the height of the pan. So over here you can see that the bottom of the pan is approximately 7.5 centimeters off of the table, and the height of the cup, looking at the bottom of the cup, would be about 13 centimeters for our low one. And coming over to our other pan here, our pan height is about the same, 7.5, and you'll notice the cup goes to just above 30 centimeters, so maybe we'll call that 30.5. All right, starting back at our low pan, notice that the sand has been smoothed out. We also pushed the pan or the sand back in the pan to allow the water to drain. And then over here we did the same thing, only this cup is higher. So before we do anything, we want to go ahead and pause here and make your hypothesis. Remember your hypothesis, an if, then, and because statement. So if the cup is higher, what do you expect to happen in terms of the channel that's created in the sand? So we'll take a look at what happens to the sand and measure the size of the channel that's created in the low pan compared to the high pan. So go ahead and pause here. Tell me, what do you think is going to happen? And then explain why. Why do you think that we would see what we would see? All right, so we've got our initial measurements recorded. We've got our hypothesis. Now I'm going to go ahead and slowly pour water into the cup here at the low height. There you see the water trickling down. And as it fills the bottom of the pan, it will then drain into the bucket down below. But notice how it's creating a channel in the sand where that sand has then been carried down to the bottom of the pan. We're going to compare the size of this channel to the one that's created in the next one. Okay, we're going to go ahead and try the same thing, only now the cup is positioned higher, and then we'll compare the size of the channel that's created. So go ahead and watch what's happening as the water is flowing. All right, there you have it. So there's the channel that was created from a little bit higher position. The next step here is we're going to go ahead and measure the size of the channel that was created for both of these. All right, we're back to the low cup here. We've got a depth of about 3.5 centimeters, and a width at the widest part also about, here it's 4, so we'll say 4 centimeters. And then the length of our channel, we'll call it maybe 17 centimeters. So that was the low one. It was 3.5, 4, and 17. So coming over here to the higher cup, this depth looks a little bit less. Looks like more like 2.5, and the width also a little less, also 2.5, and the depth here is a little bit more like 12.5. So that was 2.5, 2.5, and 12.5. In the far right-hand column, you'll see a place for observations or notes. Go ahead and feel free to describe it with words. What did you see happening for both of these? Now on the worksheet, it has a place to have a third height. We're just going to do these two comparisons. So don't worry about the medium. We just did the low and the high. So there are some results that you can use to complete that. And then be sure to fill out those analysis questions on the back. All right, so again, taking a look at your lab handout, making sure that we have everything. Please double check that you have both your first and your last name here up at the top, and then which class period, 1, 2, 3, or 4 there. Here is the comparison. We're making the height of the water low versus high and seeing what effect does that have on the size of the channel. So we're using yellow to represent our manipulated variable, red for our responding. So here for manipulated, we've got height, and then low, medium, and high was what we were planning. Responding variable, the size of the channel. So as we did this, noticed we were using the same type of sand, same type of pan. The amount of water that was in both of those was exactly the same, and the amount of angle or slope was the same as well. So your hypothesis, again, if the height is higher, height is our manipulated variable, so we would highlight that with a yellow. Then the size of the channel will be, and you go ahead and fill in the blank there with what you were expecting. Deeper, wider, longer, bigger, smaller, whatever you think. And then the because statement is you're explaining why you thought that. So here's, you've got some kind of scientific reasoning, like if it's the water is falling from a higher position, it would be traveling faster and have more force or pressure. And then down below, we've got our data table. So off to the left here is the height. That's our manipulated variable. So we've got yellow there. Here in these boxes, we've got red because those are our responding variables. We've got depth, width, and length of channel. Now here for the manipulated variable, don't forget to record the height of our cup in centimeters. So the low cup and the high one. And then you're going to record the depth, width, and length for each of those two. And again, off to the right there, observations, descriptions, words that you would use to describe what you saw. Now down below here, we've got some controlled variables, some constants. So we're going using blue to highlight that. The height of the pan goes here, and 300 milliliters was the volume of water. All right, on to the back. So up at the top, we've got a picture you're drawing what was happening. So maybe your drawing starts here looking like just the smooth sand. Notice that it's back from the edge a little bit. And then the during, so we're showing the water flowing down and then maybe spreading out. And then what was left at the end, notice we've got this channel that's created and the water is carrying the sand, so the sand is then depositing here down below. So as you're looking at our questions here, how did the water change the sand? A word that came up a lot was the word erosion. That means that those sand particles are getting carried away to a different place. Go ahead and then compare, how did that look, the channel that was created? How was it similar compared to that satellite picture we've been looking at on Mars? And then also, how is it different? Clearly it's not exactly the same. So in what ways is it different? And then finally there, our last question, what do you think about the idea that water could have caused the channel on Mars? Give some evidence to back up your reasoning there. All right, so there is a summary of our stream table lab. Be sure to turn in that paper. This was done on paper, so nothing to turn in Canvas for this one. Just turn in the paper to me as soon as you can. Thanks.